Hello, everyone. Welcome back to another episode of Tech Talk session organized by DeepLens. We do have Tech Talk session organized approximately every month. Uh, those who have registered in our group, I'll send you the link for every Tech Talk session. And today we have Manpreet Singh talking about multi-agent systems. Most of us knows Manpreet, so there is no much introduction needed. But still, I want to talk a little bit about him. And about me, my name is Harris Kilikotu, and I am the moderator for this session today. Manpreet has got extensive experience in platform architecture and software architecture in general. He uh, he worked in AppDynamics, Atlassian, CA Technologies, Citrix, Quark, and SourceViews. And currently, he is consulting on agentic AI and cloud service, cloud services, and that's pretty much about Manpreet. And today, I hope we will have a very good session on multi-agent systems. And with that, I will hand over to you, Manpreet.
Thank you, Harris. Thanks a lot. And briefly introducing Harris. Harris is my partner in crime. That's how I call him. And we used to work together in CA Technologies, probably more than 1.5 decades back. And we were in touch. And off late, we started collaborating more on the coaching side of the world. And he's currently working in Relva Technologies. Rather, he has founded Relva Technologies, and where he now leads AI-driven platforms. With that, probably let's get into the session. And a request, if all of you could switch on the video cameras. Thank you, Arun, for switching it on. Hi, Arun. Yeah. If you
Hi,
could switch on the
Manpreet. Hi.
Hi. If you could switch on the video camera, I would get more energy. Otherwise, also it's fine, no problem. Awesome. With that, let's have a quick poll. Your agent experience. Basically, your agentic AI or AI agent experience. So please type in the chat one if you have just heard about AI agents but have not tried one, or two if you have used AI agents like ChatGPT, Claude, Gemini, or three if you have experimented with building AI agents, or fourth if you have really deployed AI agents in production. Okay, let's see the chats coming in. Building AI agents. So most of the folks are at 2 or 3, which is, I guess, good spectrum, which I was looking at. So it will have a good session in that case. If there were ones, it would have been a little bit worrying, but most of you guys are 2 or 3, which is good. Okay, awesome. Now, could anybody unmute and tell us if you would like to explain what an AI agent is? What do you think about what is an AI agent? Because there are quite a few on twos and three, 2 and 3. I would be expecting some takes on what an AI agent is. Anybody would like to unmute himself or herself and talk about what an AI agent is? If not, I can probably pick someone.
Okay, maybe I can give it a shot, Manpreet.
Please,
So
thank
maybe
you.
AI is a delegate, a delegate, with this specific goal, a specific set of maybe bunch of tasks that he is or the delegate is supposed to be executing with a specific outcome. And a criteria that we're looking at to execute. It could be recursive, it could be repeat, it could be one time, it could be all those, or any of those. So that's how I would like to define
Excellent.
an AI agent.
Yeah. Excellent. So basically, you're saying it's something which receives goals and execute it in the most optimal way possible. So, right?
Right. Yeah.
Sum it up. Yeah. Cool.
Based upon the instructions or the knowledge set you have provided.
Based on the knowledge you have provided. Excellent point, Manpreet. Yeah, that's good. So both of them together. So what Arun told is more like outward facing what it does, and what Manpreet has told is something, how do we configure it so that it achieves the goal? Excellent. Anybody else would like to take any different perspective? Okay, good. Let's go ahead with the next slide, which is the agentic AI wave is already here. And we are seeing every major tech company is betting billions on AI agents. Like, for example, Claude, Copilot, Cursor, etc., are autonomous agents used by a lot of professionals. And not just these, there are like, I would say, hundreds of thousands of agents which are in the market. And prominently, at least, I would say there are hundreds of agents which are used so much by professionals. So that's something which is a change coming in last couple of years. And Gartner predicts 33% of enterprise software will include agentic AI by 2028. Now, agentic AI is more like a Uber term for saying that, okay, how do we make multiple AI agents run to achieve a business goal? So agentic AI is a superset, if I may call it, from that perspective. And agents are replacing not just tasks, but entire job functions across legal, finance, customer support, DevOps, and we are just naming it, healthcare. There are so many domains which it is basically taking over quite a few job functions. And there is a subtle shift from giving a prompt to an agent and getting the answer to giving it a goal and getting the goal achieved. Now, it seems hunky-dory, but there are certainly you could say ifs and buts over there, but this is something which is aligning with what Arun mentioned, give it a goal and get it done. Another quick check-in, answer in the chat whether you know how an AI agent works internally. Yeah, something if you think it's a black box for you, you can just put an N. If you partially have some idea what it internally does, okay, partially. Why if you have the complete idea around it? Okay. I guess most of you have mentioned partially. One person mentioned black box. We would actually stay at a very high level. We'll not go too deep into how an AI agent works, but we'll have one slide where we introduce React pattern. React is reasoning and acting. So it is the core loop behind almost every production ready agent. So why I said almost every production agent today, because there are a couple of other patterns as well, but React is the most prominently used, where RE means reasoning, ACT means acting. So in simplified terms, it is more like we give a goal to an agent. An agent internally has LLM, which is large language model running. And that large language model does its reasoning in terms of what to do next, whether the goal has been met or not. And if the goal has not been met, it does an action. It makes a tool call. It makes a call to the API, or it makes a call to some web service and gets the result. And it would actually see if now the tool result makes it think that the goal has been achieved. If not, then it would do that loop again and again of calling the tools till the time the goal has been met. Once the goal has been met, it gives the final answer. A very simplified satellite view of what an agent does internally, which is reasoning and acting. LLM reasons the next steps, get its actions done using the tools, and then finally LLM thinks that okay, now the goal has been achieved, gives the final answer to the you could say the person who asked for the goal to be achieved. Now this is oversimplified version of React pattern. React pattern is much more than this. So, but the core part is the loop around it, that where there is a loop till the time goal is not met, it keeps on calling the tools. Okay, another quick quiz. This one is a little bit different, not related to AI agent. Which restaurant wins? Let's say you and your family wants the best possible meal. Which one would you bet on? Restaurant A, it has one chef, every cuisine, one person cooks Italian, Indian, Chinese, everything in that kitchen and restaurant is done by one chef. Option B is one cuisine, one chef, where the whole restaurant is devoted to a single cuisine. Option C is many kitchens in that restaurant and many chefs, which means one chef per kitchen, which means and each kitchen serves different cuisine, and hence you can enjoy different cuisines in that meal. Okay. Most of you guys are saying C. Okay. Very good. Okay, awesome. So in a way, what you are saying is that, did you say C because you are going with your family? That's why did you say C? Or if you were alone, would you have chosen B? Anybody would like to unmute?
I chose C because it gives me chance for specialized cuisine. Like, this person is not jack of all trades. This chef, knows his job for that specific cuisine, and I would
Okay.
choose C.
Okay. With that
Many
reason,
kitchens, yeah.
yeah, please go ahead.
Kind of a buffet, maybe. Can we correlate with that?
You could say till the time that buffet, each cuisine in the buffet is made by different chef.
Yes. And is there a way to raise the hand for any query of this?
Yeah. Please go ahead.
Where I could not find, but can I ask, can we go back to the slide?
This one?
Previously? Yeah. So React, there is a way to have the React prompt as well. So then what is the difference between React prompt and the agent you are building, which actually thinks and plans as per, as I mentioned, the set of instructions. Let's say, take an example of Copilot, set of instructions you have given, knowledge you have provided, and if you are leaning your agent that can, if the answer is unavailable in the knowledge and the instructions, it can go out of that network as well.
Yes. So in a way, what you're saying, Manpreet, is more like the agent would not just have LLM, it would also have the system prompt, which would be sort of giving the identity of that agent. Probably that's what you meant, right? Yeah, true. And that's why I said this is more like a satellite view. If we go deeper, there are lots and lots. One part is the system prompt, which you mentioned. Yes, there are quite a few other parts. Yeah.
That's the main difference we can say between React prompt and the agent.
Well, agent internally implements React pattern, for which it requires prompt, system prompt, as well as the goal. To achieve that particular goal, there is a system prompt. And again, system prompt, for the folks who are not aware of it, system prompt is more like a personality of that agent or what that agent is equipped to do. That's something which we are saying as the system prompt. And ultimately, we are saying React pattern over here instead of a React prompt. Manpreet, did I make myself clear over here?
Yeah.
Cool. Awesome. Coming back to our example.
Manpreet, sorry to interrupt.
Please go.
Yeah, the system, when you say system prompt, is it where the user interacts with the agent? I mean, asking a question, probing further.
See, system prompt is not really a user interface.
Oh, okay. Sorry. Yeah.
System prompt is more like a definition of that agent in terms of what that agent does. That system prompt is sent to the LLM along with the goal. So goal is there. Ultimately, there is a system prompt as well, which is part of the agent, which is goal as well as the system prompt is sent together to the LLM to reason out what is the next step. There are more things also sent. For example, what are the list of actions available? What are the list available for the LLM to make sense that, okay, I need to call this tool. Makes sense, Raj, now?
Yeah.
Cool. Thank you.
Clear. Yeah. Thanks.
Okay, with that, we'll jump to this quiz again. And most of you said C because you'll get a choice of which cuisine to eat on that day, and hence you will get the best possible meal because it is prepared by specialized chef. Option B is where the restaurant only offers one cuisine with one chef preparing that. So I would say that, okay, if I was going alone, I would have probably picked B or C. But if I'm going with my family, I would have probably picked C. Because each one in my family might have a different taste. Somebody wants Italian that day, somebody wants Chinese or Indian. So in that case, many kitchens in that restaurant with different chef would give me optimal experience. So yes, I would agree with most of you. Now, could you relate it to whatever quiz which I mentioned about the cuisine? Could you relate it to agents? Because I have put now generalist versus specialized agent. Generalist agent is analogous to the option A on the previous screen, which is one chef every cuisine, and multiple specialized agents is more like option C, which is many kitchens and one chef per kitchen. Are you guys able to relate to that now from that perspective? Okay, awesome. Would anybody like to unmute and give an example of the generalist agent which you guys use? Any example which you could think of?
I guess most of the publicly available, be it ChatGPT, Gemini,
Yes.
they're all generalists, right? So we can ask any question. I
Yes.
mean,
Excellent.
question on any topic.
Excellent. Yeah. For example, you could say that, okay, Claude is generalist agent, but is Claude Code a specialist agent? It's a little bit debatable thing in that case. But any examples you would like to give for specialized agents? Anybody?
Codex Lovely.
Codex, okay, sounds good. So which is more specialized on the coding side of the world. Okay. No doubt.
Claude Code, I would say.
Please go ahead.
Claude Code.
Claude Code, okay. Pretty good. Anything else which you could think of which is not coding related? I know it's tough to ask.
VO3, Manpreet,
VO3, okay.
which is an agent for producing videos.
Videos, okay, awesome. Yeah, quite a few. There are quite a few in the market nowadays. In fact, even like Gamma, which is for slide building, quite a few in the market in today's world. Video making, audio making, there are quite a few specialized agents, and they're getting even specialized day by day. So this gives a decent analogy on generalist agent is one kitchen, multiple cuisine, multiple specialized agents is more like one kitchen or one restaurant, multiple kitchens, each kitchen offering different cuisine. The pros of generalist agent is one agent, simple to build, deploy, and operate, and it flexible, adapts to unexpected requests. Now you would say, hey, Manpreet, you're saying Claude or ChatGPT is simple to build. No, I didn't mean that. What I meant is that it is simpler to build from the perspective of tooling, that you might not need to give it all the tools available to you. You need not give it specialized tools from that perspective. From that perspective, it is simple to build. And it could be flexible. It adapts to unexpected requests. But certainly the con is it is a jack of all trades. It's shallower on hard tasks. So if you ask ChatGPT to actually create a report and give a small prompt, it would literally surprise you. It would give you an output which might not be great. So you have to give very sophisticated prompt using all the prompt engineering techniques, and then also you're not sure whether it would give you the right output. Or also it could be that it doesn't have access to your infrastructure. It might not be able to do those tasks even. On the other side, multiple specialized agents, they are deep and reliable within a narrow scope because their scope is limited. So Manpreet, to your point, the system prompt is very narrow for specialized agents. The tools available are very narrow with the specialized agent. So you could say small focused prompt tools, easy to test as well, because we have to test within a limited boundary over there. Cons is more like, what if you have multiple specialized agents? There needs to be some orchestration in case of multiple agents. Now, if you went to a restaurant where there were multiple kitchens and each kitchen having different chef, I'm sure that the manager or the person who is taking orders from us, that person would be having tough time in integrating or talking to multiple kitchens, multiple chefs, getting the food on the table. So it might require a lot of orchestration to get it done in case of multiple specialized agents. Okay, are we all good?
Yeah,
Comes
so means a lot of effort or investment you need to do on the performance side in case of multiple specialization.
not just performance, it's also about how do we make it reliably run. Now, if in the previous example, if let's say the person who took the order took some sushi order from you and went to a Chinese restaurant to order that, it would be a disaster.
Mhm.
So performance, reliability, accuracy, even cost, latency, all of those things come into the picture.
Yeah, thank you.
Cool, awesome. With that, let's talk about what we'll cover in this webinar. We'll cover multi-agent systems, and we'll not be able to go deeper into it, but we'll give a glimpse of coordinating multiple specialized agents to achieve a goal. We'll see an example. We'll see a couple of design patterns on how those are achieved. Rather, we'll have just one example in the interest of time, and we'll see that example where several specialized agents working together achieve what a single agent cannot. Let's see that example. The example use case is accounts payable automation. Let's say if I have a company which receives invoices from multiple of my vendors, and I need to decide whether I have to pay that vendor or I have to deny that vendor, or whether I need to review or have a human review it, have a human review that particular invoice before finalizing on the decision. So this is a very important kind of decision which has to be done. And let's say if it is 10,000 invoices per month, which are PDFs, email attachments, varied layouts, there has to be some person, if you're manually doing it, some person manually keying in, trying to do a three-way match, whether the invoice mentions, is it relevant and mapped to a purchase order? Has the goods been received or has the services been provided? It would require several days to approve, and it's error prone because it's more like every human has got a attention span and it's a long process. There is a potentially error prone over there. Now, what if we can say how AI agents can help? Again, we are not saying how AI agents would replace fully this flow, but how an AI agent can help in this, where we would have automated decision on each invoice, pay, deny, or review with evidence, not just sample saying pay, deny, or review, but it's a with evidence. It would be able to catch frauds, duplicate invoices, and even if somebody is trying to split the invoice into multiple smaller parts so that it could go through the system, how could we do that? All those things. We should be able to automate it, right? Let's quickly see the sample agent flow which I have come up with. And it's not really, I'm not really trying to say that, okay, this is the only way it can be done. But before doing that, is the problem statement clear in terms of where I could say that multiple invoices are received, and I need to match whether there have been a purchase order for that, whether the goods have been received or services have been provided. How can we automate this whole process using multiple agents? Is the problem statement good? May I have thumbs up from everybody if the problem statement is good? Everybody good with the problem statement? Awesome. Great. Please feel free to unmute and speak up or raise the hand. We should be able to address any questions. Okay, talking about the multi-agent design, as I said, this is just a sample implementation or sample design where the invoice could reach to an extractor agent, which could see, hey, this is an email which has the PDF, or it could be an image. It could basically do optical character recognition in the image and basically extract out all the details and normalize it based on the further, based on how it could pass the data further to the subsequent agents. And subsequently, an orchestrator agent could pick it up, which could say, hey, I would orchestrate between specialist agents running in parallel. Analogy, one chef, one kitchen, and there are multiple kitchens. Multiple kitchens over here is different agents. First agent is trying to do a three-way match, whether there's a purchase order corresponding to that invoice, whether the goods have been received, the services have been provided. The second one tries to detect the fraud, whether the person is trying to fraud the system by probably splitting the invoice, sending duplicates with the same amount, same purchase order, all those things could be done. And the third one could be it is trying to match the policy, whether we are allowed to pay directly to this vendor mapping, and all that stuff. So again, each of these agents, the specialist agents could have access to specialist tools, which could be specific to that particular agent. It could have different LLM, different system prompt, different tools available. Once each of these agents decides what is the next step, there could be a risk aggregator agent, which makes a decision that whether this is a clean match. If it's a clean match, pay to the vendor. If it's not a clean match, if there's an exception, if there's a fraud detected, deny it. But if it's a high risk or borderline, we could say, then let a human review it. So there is a human in the loop, as well as there is audit log captured just in case we want to go back and see the data around it that, okay, hey, why did we take that decision to deny, or why did we take that decision to pay or review? So yes, this is one sample implementation where we could use multiple specialist agents to achieve the goal for accounts payable automation, where I receive PDFs, email attachments from multiple vendors to pay. I have not reached that situation where I could receive 10,000 invoices per month. I wish it could be possible soon, but so far it's not possible. So this is a theoretical example, and quite a few companies are doing it in this fashion, and quite a few companies are doing it from the perspective of, for example, site reliability agent, which would see, hey, an incident happened. Let me actually try to, you could say, automatically detect what could be the reason. Hey, looks like this somebody uploaded a video on Instagram. Before revealing it to the public, let me actually go through the review process and approve it, deny it, or let a human or moderator review it. So it reduces overall load on the moderators, on the reviewers. So this is well-known pattern from multi-agent perspective. Now, if instead of this, if we had a generalist agent which does everything, I'm sure you would be able to relate to that kitchen example. That agent, journalist agent, would do not great job because that agent would not have access to specialist tools, would not have specific LLM or specific system prompt, and hence the need for multiple agents. Okay, I'll take a pause over here. Any thoughts, any questions from anybody?
So Manpreet, I have a quick question. Is it analogous to a distributed microservice architecture wherein each agent is corresponding to a specific capability or specific microservice that we would have?
Excellent point, Arun. Yes, I would say microservices came into the picture for different reasons, but you can draw an analogy that microservices came into the picture from the perspective of breaking down a monolithic system into multiple services for better scalability, better maintainability, and better delegation or assignment to a specific team.
Or separation of concerns. Yeah.
Separation of concern. That's again a very good design. Yes, that is one reason. And you could say there is a lot of parallels with that example and this example. Yes, there are a lot of parallels. Here, the additional aspect is the accuracy would also become better, or reliability would also become better, because these agents have specific tools to its disposal. Very similar to, let's say, if you have a task to be done, and if you, let's say, if you say certainly get a requirement from the product management to roll out a particular feature, and if that feature requires Java developers, front-end developers, security engineers, uh, quality engineers, or business analysts, so you would have a specialist roles over there to delegate. So that is another analogy for the same thing. So what you said is also true. Another analogy is more like if we generally talk about human teams where there are multiple team members in a team. Sounds good?
Yep.
Okay. Any other questions from anybody?
So, please, how do we identify the agents which would be the best, which exactly works for the, I mean, you have taken an example of accounts payable. So,
Yes.
I come from a store's background, let's say a retail point of sale background. So, how do I get the information? So, which agent would work the best to get the out of it.
Okay, good point, Kishore. So if I could understand your question, there are two parts to it. One part could be that can I pick up off-the-shelf available agents and assemble them to make a solution? Another part could be more like, hey, can I build agents myself? But how do I break down into multiple agents as such? So there are
Exactly.
two.
Yeah.
I guess the second one is yours, right?
Yes, it is my.
Okay, second one is yours. Okay, so I would say in itself, as we have the separation of concerns in microservices, similarly, we could have separation of concerns in agents. Now, the recommendation is not really to start with uh, 50 agents or 100 agents for your, you could say, application. But let's say you could say, hey, these are the separate concerns. Ideally, I would like this agent to be achieving this kind of concern or this kind of, you could say, goal to be or sub goal to be achieved. So you could say there is a starting point where there are smaller number of agents, and then as your testing goes ahead, you could break down one agent into multiple parts based on that. So yes, it is possible to do that breakdown early on, but my recommendation would be not to do over breakdown, because if you draw the parallels with the microservices world, there is a term called nano services, where we have seen people making services which just contain probably one very basic logic. For example, how do we do particular mathematical computation? And it's just relatively small mathematical computation. They would say, okay, let me make a microservice for that instead of making a library. So yes, there should not be you could say, breakdown of the agent into multiple parts. But the similar way as you could do microservices separation of concern, you could do that. Kishore, does it answer your question? You have follow-up?
It does. It does. Yes.
Oh, awesome.
So, one query, Manpreet. So,
Please go ahead.
let's say we are building this. So, as per you, what is the recommended way? Like you test your agents individually and then divide in the phases, let's say invoice to orchestrator agent and then specialist. And last, what if any of the agents fails? I mean, the outcome which is uh, needed or which is required that does not come from that particular agent.
So good point around that. Manpreet, there are a couple of aspects around that which I would like to mention. Uh, in case of multi-agent, there is a process called handoff.
Kind of. Okay.
That is, how do we hand off the work to the next agent?
Mm-hmm.
Very similar to, let's say, if engineers or go to actually Jira and provide a ticket and basically go to a Jira ticket and say, assign it to somebody else and put a comment over there that I'm done with this change, take it over, kind of thing, right? So that handoff is literally a point where we can say that, okay, we can first unit test that particular agent. Second thing, we can evaluate whether the goal of that sub agent has been achieved. If it has been achieved, all good, go to the next step, or we could say, let's retry it. So all those steps require a huge amount of thinking on how to make it reliable. So that is within the overall flow.
Framework,
Now,
yeah.
but there could be some goal-based critic agents at the end as well.
Mm-hmm.
You could see that, okay, hey, is everything over? Is everything done or not? If not, it would actually say, hey, go and review and correct the situation, kind of thing. So that is something which we could introduce the critic agent at the end as well. So in between the agents as well, and at the end as well, there's a possibility to do that. It's actually called inline evaluation, which is while the execution is happening, you're doing inline evaluation whether the goal is getting achieved or not, or should we course correct ourselves. And you could have an agent to do inline evaluation. There's nothing which says, okay, it could only be done by deterministic code or it could only be done by humans. It could be a balance of multiple approaches. Sounds good, Manpreet?
Sounds good. Yeah, thank you. Thank you so
Cool.
much.
Another good take which is done is human in the loop, which is HITL.
Yeah.
Which is very common before making a irreversible action. before making an irreversible action, or before making a high stake action, which could have higher ramifications. For example, sending out a public release or sending out an email, let a human review it in between, which is called human in the loop. Okay. Apart from that, there are a couple of other evaluation types as well. One is online evaluation, which is more like after the execution has happened, how do we do evaluation? Other one is offline evaluation as well, which again is an extension of your point, Manpreet, that before we release this agentic AI application to the outer world, how do we test it out? So there's another thing called offline evaluation. Cool. Okay. Now another unmute. Tell us if you could think of a problem which can be solved with, which could be solved with multiple agents working together. If you could recall any problem which could be solved using multiple agents. Anything which you're able to recall.
I recently worked on something, Manpreet, but we just touched upon it, wherein we are completely automating the regression detection of any application, wherein we constantly monitor metrics of a given product, like front-end metrics or back-end metrics, and keep observing any anomaly. And if there's an anomaly in any of those metrics, we raise an alarm, notify the product managers or EMs of that particular product, and at the same time try to narrow down the issue, using different agents, wherein we identify the recent check-ins, the recent the release that has caused the regression, and also to try to identify the most probable cause of that regression and try to fix it as well. So with multiple agents, orchestrated together, could do this up to 90% accuracy. Yeah.
Probably even more with the passage of time. And that's a good, actually, your source code repo could help handy, could come handy in this. Your observability might be coming handy. Your even Confluence pages or Jira issues might be coming handy. So all those might be data sources for the different agents, I believe, in your use case.
Right.
Okay, cool. Awesome. Anybody else would like to talk about a problem which can be solved with multiple agents working together?
One of the example in lending space where we haven't started working upon, but that could be eligible for uh, multi-agent use cases, that if we want to read the emails corresponding to the end consumer and want to further analyze their bank statement to figure it out, the information corresponding to a person, and needs to be feed to an underwriting system to basically tell us the eligibility of loan criteria. We are at very initial phase, but I think that could be one of the example from
No, excellent example. Yeah.
Yep.
That's overall that underwriting space is a huge, there are huge possibilities of multiple agents working
Yes.
together. Yes. Awesome. Cool. Any other takers on the problem statement which you would like to mention? Okay, cool. Awesome. But thank you, Arun. Thank you, Gagan. With that, let's move to a couple of design patterns. These are very high level basic design patterns. I wanted to leave you all with a couple of design patterns just for a food for thought. And these are not the consolidated complete list of design patterns, but a small subset of design patterns. And one of them is very common and simple, which is sequential, which you could say, hey, give an input to an agent, and that agent would say, go to the next agent, go to the next agent, and then you get the result. So it's anybody could relate to an analogy of this where we are doing sequential pattern over here. Anybody could think of any sequential pattern approach?
Maybe the last example we had in the slide.
Okay. There was few parallels over there. If we go over here, there were few parallels over there, which is more like specialist agent, but the undercurrent, if you see extractor agent, orchestrator agent, risk aggregator agent, those are all sequential. So yes, Manpreet, you're right. That is sequential. Another one is parallel. And we saw that parallel in the slide, which we saw for the invoice multi-agent system as well, which is we receive an input, we do a task breakdown into multiple subtasks, and actually each agent picks up that subtask and does it in parallel. And then there's an aggregator agent which picks up that tasks or the tasks output or the agent output and then produces the final result. That also we saw in this particular slide where the risk aggregator agent aggregates the responses from all the three agents which were run in parallel. So this slide has got the sequential as well as parallel. Okay. Anybody would like to talk about any other pattern which you have seen so far? Okay, probably I'll talk about 2 or 3 more patterns. Supervisor pattern, where we give the goal to the supervisor agent. And that supervisor agent actually plans what is to be done with this goal, divides that goal into multiple tasks, and keeps on delegating to the worker agents to do that task. Once it receives the result, it aggregates the result and then sees what has to be done next. It would go to the next worker agent, or it could say, hey, I've met the goal. This is the final result. That could be a supervisor agent pattern. Probably, I would say one possibility is, could we say the analogy for this could be the Scrum Master? In the software development field, we could say a Scrum Master receives a epic from the product management, works with the team, plans it, breaks it down into multiple user stories, assigns those user stories to different engineers, not workers in this case. Engineers get the results, and then finally the goal is met. Anybody would like to talk about any other analogy? Cool, sounds good. Next pattern is workflow. Do we really need to have, you could say, EI brought into the flow? Can we actually do a workflow where we hardwire the agents together and say first agent 1, and if the agent 1 gives an output of yes, then go to agent 2. If the output is no, go to agent 3. And if it is done, then end. If it is not done, go back to agent 1. So we could say we could marry both worlds, deterministic world and the world of AI agents, where we could say, put a workflow where multiple AI agents are stitched together in a workflow in a deterministic way, but internals of that agent are still probabilistic, which are using that React loop with LLM and action. That whole loop is happening in between. But once the agent responds, we have a deterministic check on what to do next. Okay, with this, we touched on, you could say, 4 very simple patterns. There are other patterns like console pattern. For example, if you have a high stake situation, you could say, hey, let me actually give my goal to multiple agents. Let them do the work in parallel. And then I'll decide which work is better and then incorporate that work and go ahead with that particular work, or mash up the output from multiple agents. So another one is console. There are multiple other patterns, but I thought of introducing just these 4 patterns in this multi-agent webinar. Anybody would like to talk about any other pattern around? Okay, Ravi, you have a question on any approval flow. Yes, that's also potentially a good pattern. And it is a pattern which is sometimes mixed with the, you could say, human over here. For example, if you see this high risk thing, there is a review portion over here, and which could have approval over there. So yes, that's also a design pattern which is human in the loop. Cool. Any other patterns which you are able to think of, or any other examples of the 4 patterns which we talked about, which is sequential, parallel, supervisor, workflow?
Manpreet, I want to add a comment here.
Please go ahead.
So here, workflow pattern is a super pattern which accommodates parallel and serial actions as well, right? So most of the practical business workflows might be fitting into this pattern, isn't it?
Excellent. So your point is more like, instead of saying agent 1, it could be even a combination of supervisor and multiple agents replacing agent 1. That's what your point is.
Right.
That's a very good point. Yeah. So it's you could say meta pattern or super pattern. That's the right word to use. Yeah. Okay. Anybody else would like to take on any other pattern which you're able to recall or any examples from these patterns? Okay, sounds good. Now we have done high level basics, and what next? Would you like to go deeper? So we offer a cohort, and there are actually a mix of uh, participants over here. There is one participant who has already done our cohort and is joining from there. There is one participant who is currently undergoing and part of a cohort, and there is one participant whose cohort is joining this Sunday. So you could say all the cohort members from that perspective are their previous cohort, current cohort, and the future cohort. And we offer a cohort which is structured hands-on cohort for software professionals, and which helps you create production grade AI agents. And it covers multi-agents. So we talked about multi-agents in this slide at a this webinar at a very high level. We'll be going deeper into this at a code level in the cohort. We'll discuss design patterns. We'll discuss RAG, agentic RAG, all other aspects around it. We'll discuss MCP and different ways MCP could be used. We'll discuss about A2A. We'll also discuss about memory. Memory is more, for example, we'll discuss short-term memory, long-term memory, user level memory, session level memory, all those aspects we'll be discussing. And we'll also cover observability, evaluations, and security, which is something what makes the AI agents production grade or ready for the enterprises to be deployed. So this is very important, observability, evaluations, and security. We touched base on the evaluations when Manpreet asked a question around how does agents output impact further agent execution. So we touched on inline evaluation over there. So there are two more types of evaluations which we touched in our cohort. We talk about security. Security is a different beast in case of agentic AI. We talk about agentic AI best practices in that cohort. It's a small cohort of 12 learners. And this is something which we do, Harris and I do with a lot of passion in terms of making sure that we give the best quality experience to everybody, every cohort member. And we have 16 hours of live sessions, 2 hours for 8 Sundays, starting this Sunday, evening 7:30 to 9:30. And this is our cohort details. You could scan this QR code, or even Harris has put down the link in the chat for the cohort link. And with that, the floor is yours. You can ask any questions around cohort, multi-agent patterns, or in general related to agentic AI, or if you want to express any thoughts. If not asking question, you want to express any thoughts, please go ahead. The floor is yours. We have remaining 8 minutes for you to express anything you would like to express. I'll bring the camera.
Sorry, I'm a bit confused. So isn't this session the part of the cohort that I signed up for?
No, that's Sunday.
Okay. All right. Okay. So this was a kind of meet and greet kind of
meet and greet, and it's more like not just meet and greet. It's more like we have previous cohort members also joining, the current cohort members also joining, the future cohort members, which is you and Manpreet, they've also joined in. And there are few whom we are telling about this cohort. So all the folks are over here. Yeah.
Oh, okay. So our official kickoff is on Sunday.
Sunday 7:30.
Okay, nice.
Yeah, because generally in cohorts, we have a policy of no slides. So Ronak is aware about that. Amit is aware about that. We generally go for whiteboarding, and we start with whiteboarding, and we'll have demos, we'll have assignments. So that would be there in the real cohort meeting would be on Sunday.
Manpreet, any prerequisites in terms of any subscriptions or anything that's needed on our part?
Good question. Good question. So there are one prerequisite might be that, okay, access to an LLM. And generally, you will get free LLMs from Gemini, or you could also sign up with a free account with AWS, which gives $100 credits, which is going through a little bit of an issue nowadays, but sometimes it's not an issue. Sometimes it is an issue, sometimes not an issue, but mixture of Gemini, AWS, Open Router, if you could get access to LLM. So we'll talk about that in the first session, Arun, on how do we get access to that. That is one. Another aspect is in this cohort, we demonstrate using a framework called Mastra AI, which is TypeScript based framework. So if you know TypeScript, that's beneficial. If you don't know TypeScript, then also not a problem. We would not go too deeper into TypeScript. So Harris and I would share a video, which is probably 1 hour to 2 hour, which would bring you up to speed on the basics required for TypeScript to basically start working on the cohort side of the thing, to start working on the assignments. So we'll not use extensive TypeScript, which would make you feel that, okay, what is this written? We'll try to keep it very simplified from that perspective. Because the intention is not to learn TypeScript. The intention is to learn agentic AI, which is production grade agentic AI. So second is both are soft prerequisites, Arun, be it LLM, be it TypeScript. We'll be talking about that in the first session of the cohort, as well as another aspect is more like, I would say the zeal to learn, that's more important, and we'll have good cohort. Anybody else, any questions around it?
One topic which I want to discuss with you, that is more around that a use case which I'm thinking about it these days. Say, for example, I want to basically read multiple information from multiple documents which are available across uh, the organization, or let's make it simple that I want to fetch the information corresponding to Jira from Jira, then few information from Slack, few information is available on Confluence from the MCP servers. Now, what I need is that I don't want to read it from every system each and every time. So basically, I need to create some knowledge inference layer on top of it, right? So that I can basically reduce the context size. In my opinion, if I keep reading it from every place, then at one day the context window is supposed to be gone for me, right? So in these type of the use cases, what kind of the agentic multi-agent model which we need to think of a high level approach towards it?
Yeah.
Or yeah.
Yeah. So Gagan, from the perspective of the agent which you are defining, so basically what you're trying to say is you don't want to access multiple systems. Rather, you want to consolidate the information in a knowledge graph or a knowledge base or some other database, be it vector database, be it non-vector database, and you want to work around that, right?
Very fair.
Sorry, could
Yeah, I'm with you.
yeah, cool. So I think that is, again, there's no wrong or right in architecture. I'll tell you pros and cons in that.
Fair.
While it might be your system is much more available than other systems or direct access to MCP. But on the other side, you would land up in the lots and lots of delay in your knowledge base getting updated based on so you'll not get the real-time data. So if you don't get the real-time data, would it impact your agent workflow? That is one point. If it doesn't impact your agent workflow, would it increase the cost? That's another question. If it increases the cost, by how much? So that's a decision which needs to be taken. Now, certainly there's a pro as well. Your dependency on those systems would reduce. What if those systems are down? Your agent would keep working. But then the question comes is your agent read only, or would it be updating other systems? If it would be updating other systems, you'll have to go ahead and actually still call their tools to update it. So instead of that, okay, context window would increase, and that's why you want to have knowledge base or knowledge graph or vector database for that. I would suggest that instead of doing that, if we can discuss that, how do we reduce the context window size? How do we build the agents in such a way the multi-agents in such a way that, okay, the context window doesn't get breached, which is the whole fun of multi-agent design.
Right. So that's why I was thinking more in terms of knowledge inference layer. So maybe I'm unable to put it in the right words.
Okay.
For me, the context window is something where basically I want to have that minimum information so that I can take the call on it. It's not something which is dynamic in nature. It is not something where I need to put the update in any other system.
Got it.
Let's put the boundaries over there that if it is the only use case to conclude something out of it.
Yeah, that's pretty much possible. What you're saying is very much possible. And as I said, there's nothing wrong or right in any approach. Every approach has pros and cons. The con would be data staleness. The con would be additional cost. The pro would be additional reliability because you're not relying on the, you could say, other availability of other system. But the only suggestion was that, okay, if you could potentially think about squeezing the context window anyways.
Got it.
Okay.
So
But
it's
there are, yeah,
depending on the nature of the data, which on the basis of which we need to take a call. If the nature of data is more like a constant and very rarely kind of a change, then we need to take the call.
exactly. Okay, Ravi says, I'm new to AI agent. How can I cope up with other cohort members? So Ravi, quickly knowing may I know your background, please, in terms of are you on the software side of the world or the non-software side of the world? Basically, okay, yes, working in IT. I think there's no problem with coping up with other cohort members because we generally work on the concepts and we discuss concepts and demos in every session. And then there are assignments. Assignments every week, and every cohort member is supposed to do those assignments on his or her own. So in a way, the assignments, the more you spend time, the better would it be for you. But conceptual clarity in the demos in the sessions, you would be able to understand it because you are in IT. There would be demos which involve coding. So if you understand very high level code and willing to understand TypeScript, that's not going to be a problem. Basically, what I'm trying to say that you have your own journey. You need not cope up with other, you could say, members. Okay, Arun says, I'll share my assignments with you. Don't worry, I share the solutions as well for the assignment, so it's good.
And if Gagan is joining cohort, I can share in the first session. So I'm using MCP, Confluence, and Jira. It's working well along with some knowledge based given to the agent.
Thank you, Marvin.
Cool, awesome.
Thank you so much, Manpreet and
Thank you,
Haris and everyone. See you on Sunday.
Thank you very much.
Thank you, everyone.
Thank you, everyone. Bye-bye.
Yeah, bye.